Thanks to join us today. And the webinar today is gonna, we will have in this webinar Sebastián Ochoa. Sebastián Ochoa is an agricultural engineer, MBA with a master in agricultural technology, and is a worldwide known blueberry consultant. And he is managing more than 12,000 hectares of blueberries worldwide. And he is present in countries like Chile, China. Is also present, of course, in South Africa. Is present in Peru, Mexico, United States, New Zealand, Zambia, Italy, Ecuador, and Austria. And today we are going to talk about the importance of calcium and post-harvest in blueberries. So, Sebastián, I give you the word now.
Thank you very much, Juan. Good afternoon, everyone. I hope you are doing very well as your families. I want to thank to member company, especially Juan Jimenez, for having invited me to give this talk, and all of you for being present. I'd like to start showing you some pictures. So these photos, you can see some problems with which the fruit arrives to its destination. Here in this picture, we have some soft fruit with onset of rot. Here, fruit with botrytis. Here and here, starting a botrytis disease, and increasingly common is this problem. This problem, the name is collapsing of the fruit. So we have to understand that we produce a product for export or even for internal consumption, but a little quantity of fruit. And many times this fruit is consumed directly from a clamshell as a snack. So we must to make a fruit highly resistant for the travel. Here you can see a picture. This in the United States, in New York. I took these pictures in the downtown in Manhattan in winter, maybe 15 minus degrees Celsius degrees, and they sell fruit on the street. The people come to this store and they buy the fruit and they eat directly from the clamshell. So and this little store has a worm system because they don't use the fruit will be frozen. So it's very important to send to the market a good quality fruit. Here you can see a fruit on the store. Same is a store with the ambient temperature in the United States. This fruit is in South Africa, very good quality fruit. Is a finalist domestic market. China. This is a little store in the street, China, in the south of China, and they want big fruit, good quality, very firm, crunch fruit with a good bloom. So if we want high prices for our fruit, we must to sell a good quality fruit. This is in New Zealand. New Zealand is a very, very good market, but you can see the quality is very bad. When I took this picture, the fruit is soft, shriveled, some collapsing without bloom. This is in Australia. The fruit looks not perfect, but looks good. This is in Switzerland. This fruit is from Peru. The size you can see is not uniform. Big fruit, small fruit, without bloom. So the people finally there is on French. So the picture show a fancy, a very fancy store in the downtown of Paris, and they sell very nice berries, blackberries, blueberries, raspberries, and in a room, a storeroom without cold finally, and the fruit must resist obviously the high temperature. My idea was show you the quality and the problems on post-harvest. So as you can see, the major of the fruit must be prepared to withstand more than 30 days of travel and then service in a store at room temperature, as I told you. But it is essential that the fruit is built to withstand this. There is where the calcium play a critical role. I want to tell you the calcium in blueberries doesn't play an important role in the initial firmness of the fruit, as this does in other species, but rather that its role in one of the stability of the union between the cells is give a resistance to post-harvest disease and delays the senescence and softening of the fruit. The content of the calcium on the fruit depend directly on the amount of assimilable calcium present in the soil, the pH. The pH is very important. When I have a low pH, I don't have available calcium on the soil. And from the presence of other cations in the solution of the soil, because they interact in their absorption, the cations are the ammonium, the potassium, magnesium. From the activity of root hairs and or new roots, in the case of the blueberry don't have root hairs, just the new roots are the responsible of the absorption, the nutrients. And from the transpiration flow on the plant, because the movement of the calcium inside the plant is not active, it's passive. Okay, here you can see the range of pH on the soil between 4 and 10, and what happened with all of the nutrients and the availability of the nutrients. There is a myth on blueberries. It's a myth because about the pH, because the blueberries come from the from North America, the northern areas from North America is on Washington State, Oregon State, and the south of Canada, British Columbia. The natural pH of the soil is acid, between 4.5 and 5, but doesn't mean in soil chemistry that this pH is the ideal for fruit production. Here you can see what happened when I go to pH between 4.5 and 5. The availability of the magnesium, calcium, sulfur, potassium, phosphorus, and nitrogen is very low. Boron 2, copper, molybdenum. Molybdenum is very important in all of the metabolism of the nitrogen because it's the responsibility to make the enzyme to metabolize the nitrate. So in soil chemistry, the ideal pH is between 6 and 6.5, because there I have all the nutrients in a good availability form. The problem with the calcium always is the pH on the blueberries, because when I took some guide from internet about the blueberries, the people from United States say, no, the blueberries growing in a natural acidic pH and needs between 4.5 and 5. Yeah, naturally they grow in this kind of soils and with acid pH, but doesn't mean this is the ideal pH for a fruit production. The ideal pH is between 6 and 6.5. The problem on the blueberry is a calcifugus species. The blueberry cannot tolerate the bicarbonate and the calcium carbonate on the soil, because with the presence of those elements interrupt the metabolism of the iron, and the plant turns chlorotic. So finally, I must to destroy this form of this bicarbonate and calcium carbonate with acid, but the pH must to be 6. Okay, here you can see the interaction between the different elements. So when I have a strong antagonist, weak antagonist, synergisms, and negative synergisms, you will have this information when I make the fertigation. You can see it's not, if I want to put calcium into my plant. Remember, the calcium, the plant use the calcium when I have set fruit. When I have set fruit, I have the cell division, and in the cell division, it's very important to put the calcium, because I will in this moment I will have the calcium, the bonded calcium. So if I'm using some special calcium to increase the bonded calcium, to increase the calmodulin, I must to be careful with the antagonism, with all of the cations, with the ammonium. I have antagonism with phosphorus because form a salt with calcium and phosphorus, as is in, an insoluble salt with potassium, with magnesium. So you will have this information to check on your home later. Finally, the forms in the plant is with the soluble mineral is calcium sulfate, insoluble mineral forming phosphate and carbonates, especially in organic form is oxalates and pectates, is the bonded calcium is pectates, and calcium, despite being present in a certain amount in soluble form, doesn't move easily in the plant. Now you can see a picture. You can see what happened with the cell wall. This is the middle lamella with this, all of this black circle is the bonded calcium. Finally, the bonded calcium stick the cell wall on the middle lamella, and then you can have the calcium on the plasma membrane, on the cytoplasms, on the vacuole, and endoplasmatic reticulum. And in this form, I can have the calcium on in a protein. The name is calmodulin. It's very important. I will speak about that later. The absorption calcium is absorbed by the new parts of the roots. Very important for the blueberry, new parts of the root, because the blueberries don't have radicular hair. It is possibly absorbed with transpiration by xylem, as is very retransported via phloem. Once the calcium ions are taken up at the new parts of the root, they progress cell by cell until they reach the xylem ducts. It's very, very slow. So if I have problem in my irrigation, I cut the movement of the calcium inside of the plant. So it's very important, the irrigation must to be continued. Okay. Here you can see a picture of the blueberry root system. It's very superficial. I have the most quantity of the root on the first 40 centimeters. Is fibrous and of a little extension. The roots don't have root hairs, so it's just the new roots. They're responsible to make the absorption, and the calcium enter on the root 2 millimeters before the Caspary band, and the Caspary band is always on the tips of the roots or in the new roots. So it's very important to continually make new roots to get the absorption of the calcium, this kind of roots, white roots, okay? Here I can see the new roots, make the absorption of the nutrients, then I can see this roots for is the anchor finally of the plant. This is my objective finally, to get this kind of roots, white roots. In climates in some parts of the world with like the south of South Africa, the Capes, when I have an autumn, winter, spring, and all of the station of the year, because the north is different, it's more equatorial weather. I have this kind of growing. So the temperature of the soil give me the starter of the root development. All of the roots are quiet, are in dormancy below 7 degrees. And when I have more than 7 degrees at the end of the winter, is when it started the spring, I can see the movement of the roots. The roots start to increase the growing, okay? The grow increase, and when I start all of the production season, the flowering, the set fruit, and the ribes, the growing of the root start to decrease. And then when I enter at the end of the summer in autumn, and the soil start to decrease the temperature, because when I have more than 20 degrees, the development of the roots stop. So when the temperatures go down at the end of the summer, I have the big peak in a root development in the year. So always I must use the rooting or the root stimulant in this case here in the spring and here in at the end of the summer. But if I want more, finally more food for my fruit, more element, more nutrition, more dry matter, I can increase this peak here, giving more root stimulant the plant. It's a management that I can make. Here you can see root system in a sandy soil. And this happened in equatorial areas, like, for example, the north of South Africa, in Zambia, in Peru, or south of China. I have just one big peak of the root development. When I finish the harvest and I make the pruning, I pruning here, I make the prune, and then the branches start to grow. The root start to increase the development, increase, and when I start all of the process of the reproduction, the flowering, then the set fruit, green fruit, the growing of the root start to decrease. So here I can use the same idea, the last picture. So I can increase this peak to increase the absorption of the nutrients, because I need new roots to make a good, finally, a good nutrition for my fruit, especially the calcium. Here I can see what happened with the root extension in millimeters on time when I start to increase the calcium quantity in a soil solution or in a solution in a hydroponic. So the root extension is connected with the quantity of calcium that I put on the soil. The calcium is a root stimulant too. And there's a study when I stopped the calcium nutrition in an hydroponic system, the root stopped to grow. You don't have to grow if you don't use calcium on your soil. It's very interesting. So the movement in the plant and the deficit. Calcium is transported mainly in the xylem. Any factor that influences the loss of water in the plant cut the movement of the calcium. So I affect the calcium nutrition if I have a loss of water. Calcium, being a relative immobile element, follows the transpiration flow on the water and thus translocate more slowly to organs that maintain a low transpiration rate, such as enclosed or expanded fruit and leaves. That to leaves with high activity transpiration. So for this reason, always I have disorders of calcium in a fruit on shadow inside of the plant. So it's very important to make a prune, open prune. I must to looking for a fruit outside of the bush, not inside of the bush, because if the fruit is inside of the bush, the transpiration rate is very low, so the calcium cannot go to the fruit. And always I will see on the new shoots, on the new leaves, some calcium deficiency, because the calcium goes to organs with a more transpiration rate. So once incorporated into the tissues of the plant, it is immobile, therefore a constant contribution is always necessary for growth. Calcium deficit must be sought in acid soil. We spoke about that in a rainfall or saline soil, because the rain wash all of the calcium, or saline soil they compete with the sodium. High levels of potassium, magnesium, or ammonium always compete with the calcium because are cations. In situation of high transpiration flow, the organs with a lower rate of transpiration, fruit and internal leaves, develop with calcium deficiency. It's very important to have the fruit always outside of the bush, no onto the bush. The prune is very important. Here you can see the calcium and boron complex deficiency. Boron is responsible of the movement of the calcium too. So this orchard was without calcium nutrition. It was in soil, and the grower, I don't know why they didn't use calcium, and you can see with all of the new shoots are with calcium deficiency. Functions of the calcium. It acts as part of the protopectin structure of the middle lamina at the primary cell wall as a cementing agent. Is the calcium pectate or bonding calcium to hold the cells together. It's a structural function. So it's very important for the integrity of the membrane. In the middle lamina, calcium is bound to the complex of protein and pectins, to which is comfort resistant against attack by polygalacturonase enzymes responsible for hydrolysis. So if I have more calcium inside my fruit, the polygalacturonase enzymes cannot work and destroy finally the structures and accelerate the senescence of the fruit. Low levels of calcium in this area reduce its resistance to enzymatic degradation, and a characteristic symptom of calcium deficit in some tissues is the disorganization of the cell walls and collapse, finally, of the affected tissues. This is the collapsing that I'll show you the pictures. It's very important on the post-harvest of the fruit. It's also very important in the development of the root. As I told you, it's necessary at the level of division and elongation of the cell and the neutralization of the hydrogen ions. Finally, the calcium nutrition regulates nitrogen absorption. It acts in the transport of sugar and proteins inside the plants, neutralizes organic acid, the calcium oxalate. It modulates the activity of more than 150 different enzymes. Counteracts the effect due to excess of other cations, for example, potassium, sodium, magnesium, ammonium too. It favors the formation of nodules in legumes, is essential in the selective of membranes, participating in the water economy of the plant, is the contrary role to the potassium, in the sodium potassium pump, actively participate in development of the pollen tube, and in 1090 in the 80s, calcium is known to have an indirect ensemic role. The name is calmodulin. It's a protein with 148 amino acids and 4 calcium atoms that is found in the cell wall. This is very important. This enzyme acts as second messenger, activating a calcium ATPase, whose mission is keep the cytoplasmatic calcium level low. In the level of free calcium rises, the action of many enzymes is inhibited and premature senescence is triggered due to the production of ethylene. Finally, with this, I can I can stop the effect at relating of the softening, mealiness, blackening of some fruit and vegetables. Finally, is the senescence. When my fruit turns soft, turn blackening, is all of the situation that occurs when my fruit start to die. The reason is the works of enzymes, but I can inhibit the enzyme with the calmodulin, and strongly inhibit the action of pectolytic enzymes. The pectolytic enzymes are the fungus on post-harvest. They make the pectolytic enzymes to broken all of the cells and enter onto the fruit. That you can see here what happened. This is an example in tomato. This is a common tomato variety, moneymaker, and this is a genetic modified tomato variety. This is the calcium supply in a ppm, and when I increase the calcium supply, the calcium content in the shoots increase, obviously. You can see increase a lot, and the disease development, the percentage of wilted leaves with the Clavibacter is a bacterial disease, start to decrease. And you can see the difference is very high in the moneymaker variety, and in the genetic modified variety is very important too. Without calcium supply, you can see the percentage of the wilting leaves is more than 50%. But with the 300 ppm of calcium goes to 8. So the important and the resistance of the disease in the plant and in the fruit is very important if I make a good calcium nutrition. So I will show you very short to experience that we made with the evaluation of effect of the application of mobily calcium, wind calcium, member routines, and silicon. This is a silicium product, and a calcium borrow tracker on the development of the plant and the quality of the fruit in the blueberry. We use those products. Mobily calcium is a calcium oxide with the free amino acids, and we apply 1.5 kilogram per hectare with the irrigation system. Member wind calcium is a calcium oxide, magnesium oxide, calcium fulvates, and we applied 10 liters per hectare. This product is the routine member is boron, iron, manganese, molybdenum, zinc, magnesium oxide, and routine power extract is lignosulfonic acid is for the complex agent, and we applied by irrigation 4 liters per hectare. And a member silicon is a silicium oxide. We made a foliar application, and a member calcium boron tracker is a calcium oxide and boron with a complexing with a gluconic acid with a foliar application. And the objective was determine the effect of this product on the mineral content in the blueberry plant, determine the effect of those products in the development of the blueberry plant, and determine the effect of this product in the fruit. The area was in south of Chile. South of Chile, we use a northern high bush variety, but we have a legacy variety. Is a cross between northern and southern high bush, so it's more similar to the southern high bush varieties. And we applied 5% between 5% of flour to 100% of flour, all of this product, and to set fruit the same, and set fruit plus 15 days the routing number. In the treatment, the TO was the control, is the management of the farm. T1 mobile calcium and wind calcium. T2 is mobile calcium, wind calcium, and member routing, and T3 member silicon and member calcium boron tracker. The test of the mineral analysis on the fruit, you can see we have difference with more calcium in all of the treatment, but with a statistics difference, positive difference in the T2 and T3, and with the total calcium and the soluble calcium, we have the same, and the calcium bond, the bonded calcium is very important. We have a big difference in the 3 treatment, but with the statistic positive difference in the T1. So finally, for calcium and soluble calcium, T2 and T3 were statistically higher and different from T0 and T1. In the case of bonded calcium, T1 obtained the highest value. All analysis share that TO was the lowest. And firmness of the fruit harvest at the beginning of the season by treatment, we use a Durofel. So in a TO, we got 48 of Durofel, but the highest one was with T2. But finally, on the post-harvest, this is 30 days after the harvest and 60 days after the harvest, what happened? You can see we have difference finally in the T3. It's the most important difference between T0. So finally, we have more firmness on the fruit in the post-harvest with the T3 treatment. And here we have the middle and the end of the season harvest is Spain for the treatment start to increase the firmness with the calcium treatment. And regarding the Biggs degrees, it's very similar. Just a half of point of different, but without the statistics different, but it's similar. Is similar. 30 days is similar too, and 60 days. We have a big difference with the treatment in comparison with the T0. The acidity is more. The treatment is important because the acidity give us more resistance to the diseases, and with the static this difference. And here you can see the picture of the plants. I don't know, Juan, you can see the picture?
Yes, Sebastián, we can see it.
Okay.
It's going quite nice.
Okay, it's a very big plant, very nice, huge plant with 25 tons per hectare. You can produce, if you want, 40 tons per hectare, but obviously we remove with the pruning to get a high quality fruit. And this is the evaluation of firmness with the Durofel method. This is the fruit. And the second one is the evaluation of the effect of the application of silicon, Foli Plus, Mobilica, and Winca on the quality of the fruit. We use Foli Plus. Foli Plus is free amino acid, organic nitrogen, kelp extract, reducing sugars, organic material, cytokinin, phytohormones, organic acid, mannitol. The objective is determining the effect of this product in mineral content of the blueberry plant and the effect on the quality of the fruit. We made this trial in the same place in the south of Chile. We used the product in 50% of flowering and 10% of flowering and set fruit. Using Mobili calcium, wind calcium, and silicon calcium in the two first one, and then in the last one, we add the silicon, the silicium, and Foli Plus. The T0 is the control, is the management of the farm, and T1 is with just the silicium, and T2 is all of the products. So we got a calcium. In a green fruit is not important. The importance is here in the ripe fruit. The calcium content is similar, but in soluble calcium we have more on the T0. But here the bonded calcium that is the most important because it's the calcium in the middle between the cell walls. We have a statistic difference with more bonded calcium in the T1 and T2. The firmness of the treatment was at the initial on the harvest. We have more firmness on T2. The reason here is the silicium. The silicium give us more firmness at the beginning, and on 30 days we can see a similar firmness, but on 45 days we can see a difference between T1 and T2, and the T2 we have more firmness than T0. So the reason here is obviously is the silicium. And finally, on 60 days after the harvest, we have more firmness in T1 on T2. Here you can see the fruit, all of the pictures. Here is a TO, here is the treatment 1, and here's the treatment 2. It's very nice fruit. This is the evaluation of firmness and the Durofel method. This wasn't Camellia, the variety. I forgot to tell you the variety. Camellia is other cross between Southern Highwoods and Northern Highwoods. It's from Georgia University. That's all. Thank you very much. And I will give the word to Juan.
Thank you so much, Sebastián. It's very interesting always to hear you. And please, if you have any question, you can send it to us into the questions and answers section below and into the right. And after my presentation, we can answer those questions. Thank you so much, Sebastián.
No problem.
I will continue with my presentation. And before I start, just to apologize for the initial technical problems that we had. But let's continue with my presentation. Good. Is just to talk about Mobilica, one of the main products Sebastián tried in the trials. He just showed us. And it's just a quick explanation about the product, and just to understand how the product works and why we had the results Sebastián just showed us. And basically, Mobilica is a product that helps us to not just to improve the uptake of calcium by the plant from the soil, but also to improve how the plant uses the calcium inside to prevent problems like cracking, to improve post-harvest life, of course, to increase the calcium and to use better the calcium inside the plant, to reduce bitter pint and hardness, and to increase hardness in some fruits. The composition of the product, you can see it has 18% of calcium and 2% of free amino acids. But the real effect is done by Packard. Packard is a patented molecule, patented by BioBert, that is a promoter of absorption of radicular calcium, and is the one in charge to make the effect on the calcium and on the plant. It's a solid product with a neutral pH, and it's always to be applied by soil applications. It's free of heavy metals, free of chloride, sodium, and it has a good visibility and a good compatibility. And just explaining quite quick the functions or characteristic of the Packard is a assimilator of calcium for the root, by the root, and it helps to make that synergy of the calcium in the cells, as Sebastián explained, to create that bound calcium. It facilitates the absorption of calcium by the plant and to metabolize or use that calcium by the plant too. How the product works? Well, the product has two ways of working in the plant. One is make an impact on the endogenous auxins in the plant. And when we don't have the Packard applied, normally the plant increase some concentration of a specific enzyme like this one, endo 1.4 beta gluconase, and that enzyme is responsible to degrade some cell walls in the tissues of the fruit in this case. And when we apply the Packard, we increase the auxins, the endogenous auxins of the plant. And when you increase that auxins, you decrease the concentration of this enzyme. And once you decrease that, you can keep the cell walls in a better structure in the tissues of the fruit. And that helps us to increase the firmness of the fruit, to decrease the ripening, and that gives us a better post-harvest life, and to improve the handling and transport of our fruits. And the other way the product works is basically, as Sebastián explained before, with the calmodulin biosynthesis in the plant. When you don't have the Packard applied, the calmodulin synthesis is not higher, and you have a lower concentration of these calmodulins in the plant. And when you have that low concentration, the plant cannot use or take the calcium in the best way. But when we apply the Packard, we increase that concentration of calmodulins in the plant, increasing the absorption capacity of the calcium, and help the plant to use the calcium to increase the firmness, to reduce cracking or other calcium physiopathies, and to decrease bitter pit, for example, in apples. At the end, the Mobilica is like a pump, in our soils. Helps the plant to take the calcium in the soil and pump it into the areas, the higher areas in the plant, to fruit, leaf, etc. help us, of course, to decrease the physiopathies of due to lack of calcium, and also provides a little bit of amino acid. And another characteristic of the product helps to move the calcium in the soil into the plant, promote that absorption, improve hardness, and reduce the cracking. The best moment for the application, it can change from some crops. In the case of the blueberries, is in blooming, in flowering, when is the higher requirement for calcium in the crop. Yeah, that is the correct moment, just before that higher requirement, just to provide the plant with enough calcium for the setting and the fruit development. And of course, Mamber mobilica is not a calcium source. Yeah, it has some calcium, but it's not a calcium source. We have to apply it with a calcium source. The mobilica needs calcium in the soil to pump it into the plant. That's why we need to apply it with Winca. Is our application strategy. Winca is one of the other products Sebastián mentioned. It has 9% of calcium and 25% of calcium fulvate. And as Sebastián said, the dosage is between 10 and 20 liters per hectare. And the same with the mobilica, and both have to be together. One is the source of calcium, and the other one take that calcium and pump it into the fruit, and help us to reduce cracking, to increase the hardness, the firmness of the fruit, and to improve the post-harvest life in our fruit. In this case, of course, the blueberries, just to avoid the problems that Sebastián showed us at the beginning of the webinar. Well, we can use it in several crops. We can use it in blueberries, of course. We have a really nice experience in blueberries, but also we can use it in cherries, in table grapes, apples, stone fruits, of course. And our strategy or our recommendation for the mixture is to combine not just the Winca and the mobilica, to use also the Mamber silicon to improve that firmness, to reduce the loss of water of the fruit, and to keep a nice shelf life for our fruit. And that's it. Thank you so much for this webinar, to sign up and to share with us this time. And of course, let's go to the main questions and main questions that you have. Well, we don't have too many questions, Sebastián. Actually, okay. Let me check. One of the questions was done by Vlad Bond, and I believe he referred to one of the first graphic you show, and he asked, what is negative synergism? I believe he referred to the negative synergies between the elements.
What is?
Yes, what is negative synergism? Synergismo.
Okay, it's an element with the same charge. They repel the elements because the elements with the different charge, they are attracted by them. But when they have the same, is
repelling.
Finally, that means.
All right. Thank you so much. And another question is for David Ngatse. Is foliar calcium
and the plant made a selection obviously when you have more because the plant to take some elements, for example, when the plant take a cation, the plant expels cations from the roots. If you have other cations compete in the entrance of inside the plant, so finally if you have more cations and with more concentration, the plant cannot take the calcium. For example, if you have more potassium or you have a not correct balance on the soil with the cations in order. So finally, the plant start to take more potassium or more magnesium and cannot take the calcium.
Oh,
that
okay.
means the negative interaction.
All right. Thank you so much, Sebastián. Another question is from David Ngatse. He asked, is foliar calcium application beneficial to the fruit when the fruit has passed pea size?
Hello, David. The foliar calcium application works when you have the set fruit is between flowering and the green fruit. After that, you don't have effect. And the foliar application is very important. The source and how is make the product finally, the quality of the product, because a lot of product doesn't work and make nothing in the spray application.
And another question is, let's say, related. What is the recommendation to apply calcium foliar calcium or by fertirrigation?
Fertirrigation.
Fertirrigation is the best way to apply it.
Yes.
All right. And I believe that was the last question. I don't know if somebody wants to ask another thing. And yeah, that is the last one I have.
Okay.
Well,
thank you very much for all of you, and take care, and a big greetings for you and some people that I know in South Africa, and so a good glass of brandy to give the fight to this disease. So take care.
Yeah, thank you so much, Sebastián, to share your knowledge with us, and thank you all to connect. And we will send you the presentation on PDF. And we will send you the link of the video of the presentation. It will be in our YouTube channel too.
Okay.
Thank you so much.
Bye. Take care.
Bye-bye. Thank you, Sebastián. A big hug, man.